Welcome to the lecture series on numerical methods, a finite difference approach. And in this approach, in the last lectures we have discussed one-dimensional parabolic equations and their solution methods. And in the present lecture, we will just go for these parabolic equations in two dimensional or two dimensions, and we can just use like explicit method, implicit method, or like semi-implicit method, that is Crank-Nicolson's method to find the solutions. So, if you will just go for this parabolic equations in two dimension, then this equation can be written in the form like del u by del t, this equals to del square u by del x square plus del square u by del y square, where we will have this boundary that is just defined within this region like x lies between 0 to a and y lies between 0 to b. So, if you will just see here, this is a two dimensional problem, means we will have like three coordinates here. So, one is x coordinate, another one is y coordinate, and another one is a t coordinate here or time coordinate here. But especially since space coordinates, we are just varying in the x direction and y direction. So, that is why it is called the parabolic equation in two dimensions. And if you will just deal such type of equations, so we need the boundary conditions at two boundaries, that is especially if we can just define the boundary in the form like x equals to 0 to x equals to a here, then y equals to 0 to y equals to b here, then we will have a third increment that is in the form of t there. So, especially we can just move in the x direction, that is incremented with the space length or this grid size del x here, and if we want to move in the y direction, we should have to consider this grid size as a del y there. And if we want to move to the next approach from the initial approach or this initial steps to the next time step level, we have to move this time step in the direction of del t there. So, for this problem, especially since we need like three conditions here. So, first condition is it can be prescribed u of x y 0, this equals to g of x y at t equals to 0, that is initially this condition should be provided at each of the grid points. Then some kind of boundary conditions, so that is prescribed at x equals to 0 and x equals to a. Then some kind of boundary conditions, so we should have to know at y equals to 0 and y equals to b. Suppose in this problem Dirichlet conditions are prescribed at all these sites. This means that u is specified or u is given at all of these boundaries. To solve this above problem, if you will just go for the solution method, first we have to subdivide these intervals x lies between 0 to a and y lies between 0 to b into m sub intervals in the x direction and n sub intervals in the y direction, and each is of width del x in the x direction and del y in the y direction. Hence, since we are just considering here m subdivisions in the x direction, so that is why you can just write this total length, that is nothing but m del x. This can be defined as like a minus 0 as a there. And if you just go for y direction here, the total length it can be defined as b equals to or b minus 0, this can be defined as n del y here, since each grid space length is del y in the y direction here. So, if we want to see here, then we can just find that these three directions it is just represented in the graphical sense here. So, x just represent in the like horizontal direction here, and y is the vertical direction, and y is in the like plane section direction here, and t is the vertical direction here. Since we are just denoting this subdivision of x axis as the I substitute, so that is why we can just write this as xi here, and your starting point here it will be x0 equals to 0, and last point it will be xm equals to a here. And on the y axis, since we are just denoting here the j coordinates, if you just see, so that is why your starting coordinate here y0 equals to 0 here, and last point yn equals to b there. And we shall compute all the unknowns that is placed on these grids here. for like variation of I equals to 1 to m minus 1 and j equals to 1 to n minus 1 for different t values. So, assume that u are known to us at the kth time level. So, if kth level values are known, this means that if the boundary values are known to us, then the next immediate level we can just proceed by considering this your boundary level values for the next iterated level calculations. So, if suppose k equals to 0, suppose here initial level, then all values are known to us along the first boundary there. And further increments, it can be calculated with the time as a increment, that is in the form of t equals to k del t here. Since in the first step we can just consider t equals to 0, then the second step we can just consider t1 equals to del t, then third step we can just consider that as t2 equals to 2 del t. So, likewise we can just move. So, this is the figure which shows all this time domain and also this space grids that is formulated in the x and y coordinates. So, if you just go for the solution in explicit method here, and if we want to discretize this equation del u by del t equals to del square u by del x square plus del square u by del y square at the mesh point I j k here, since x represents the ith coordinate here and y axis represents the jth coordinate here and k represents the time level. And if you just approximate this time derivative by a forward difference approach and a space derivative by central difference approximations here, then we can just write this del u by del t term, since there is a time variation. So, we can just consider there is a variation in the k here. So, that is why we are just writing u I j at that particular grid point, since in the space coordinate if you just see I j is the coordinate there and time means it is just in the upper level, it is just moving there. So, that is why we can just consider this space grid size is fixed there. So, that is why we are just writing u I j to the power k plus 1 minus u I j power of k. See, since this k plus 1 represents this velocities or this temperature at the time level 1 there, if you will just consider k equals to 0 there. And if you will just consider like u I j 0 means it is can be taken from these initial conditions. And that is why it is just written in the form of u I j to the power k plus 1 minus u I j to the power k by del t. And the order of approximation already we have discussed that it will just consider as order of del t here, first order approximation it will just take, since we are just considering here this forward difference approximation. And if you will just go for this space coordinates here in the x direction, we can just write this central difference approximation at kth level as u I minus 1 j k minus 2 u I j k and then u I plus 1 j k here by del x square, and its order of approximation is order of 2. So, that is why it is just written as order of x square here. And if you just go for like del square u by del y square term, so then we can just take the central difference scheme at I j coordinate. So, it will just consider one step backward and one step forward there. So, that is why it is just considering j minus 1 point and j plus 1 together with a j point there. So, its order of approximation it is just it has considered also second order of approximation. So, that is why this higher order terms it can just occupied with this power of order 2 afterwards. So, if you just neglect this higher powers of x and higher powers of y, that is in the form of del x and del y, and also this first order term of del t, then we can obtain this expansion as u I j power k plus 1 this equals to u I j power k plus del t, since we are just writing u I j to the power k plus 1 minus u I j by del t. So, that is why del t can be multiplied in the right hand side and u I j can be taken to the right hand side. Since if you will just see right hand side, we are just keeping all of these known values there, and I is varying from 1 to m minus 1 and j is varying from 1 to n minus 1 there. So, if we will just use this formula at k plus 1th level, then the scheme will be stable whenever we will have del t into 1 by del x square plus 1 by del y square, it should be less or equal to half. Since already we have discussed that explicit scheme is stable, whenever we will have like del t by del x square, it should be less or equal to half. Since for like one dimensional sense, especially we are just writing our one dimensional problem, especially we are just writing del t by del x square, it should be less or equal to half for stability of this explicit scheme. So, that is why when it is extended to two dimensional sense here, since two coordinates are involved like del t by del x square and del t by del y square. So, we can just consider, so both these values sum should be less or equal to half here. So, if in a particular sense we will just consider like del x equals to del y, equal grid space or equal grid length here, then we can just find that uij to the power k plus 1, it can be written as, since uij to the power k, it is present here, uij to the power k present here, uij to the power k present here. So, that is why it can just considered here as 1 minus 4r into uij to the power k here, since r is defined as del t by del x square here. And if you will just write this like I minus 1 and I plus 1 terms here, so that can be written in the form of r into ui minus 1 j k plus ui plus 1 j k here. And if you will just write like j space coordinates j minus 1 and j plus 1, so it can be written as r into uij minus 1 plus uij plus 1 k here. So, for the further computation, if you will just implement Crank-Nicholson scheme for these two dimensional parabolic equations, then we have to discretize this equation at the mesh point ij k plus half, since we are just considering half of the time level there, and then we are just taking the average. So, if you will just approximate this time derivative by central difference and space derivatives by average of second derivatives at kth level and k plus 1th level by replacing the central difference, that is especially if you will just write here del u by del t at the grid point I j k plus half. So, this will just give you this u discretization at k plus 1th level minus u at the kth level divided by your 2 del t. So, and the space coordinate, if you will just see here I j k plus half here. So, if you will just take this averages at the grid points I j k and I j k plus 1, especially we can just average the space coordinates in x and y direction there. So, if you will just consider this central difference for time derivative here, so then it can just represented uij at k plus 1th level minus uij at kth level divided by del t, and since it just takes the central difference approximations. So, this order of approximation for like a space coordinate, it you can just consider order of del x square plus order of del y square here. So, that is why this average schemes, it can be considered as a half into uij ui minus 1 j k minus 2 uij k plus ui plus 1 j k divided by del x square plus uij minus 1 k minus 2 uij k plus uij plus 1 k here by del y square. So, this is especially if you will just see, we are just considering this one in the kth level here, and if you will just see all these points, we are just approximating at k plus 1th level here, and this order of approximation especially it is just considered in the form of like order of del x square plus order of del y square here. So, if you will just neglect this truncation error, we can just write the above equation, that is minus del t, since if you will just see here, we want to separate this k plus 1 terms to the left hand side and kth term to the right hand side, since kth level values are known to us. So, that is why we want to kept that one in the right hand side here. And if you will just see here, so some of these values that is u I minus 1 coordinate values and ith coordinate values and I plus 1th coordinate values all are unknown in the k plus 1th level, and some of these coordinates if you will just see j minus 1 and j plus 1, this is also unknown values here, and especially if you will just see here, that is a 2 ui j k plus 1 and almost here it is also occurring like minus 2 uij k plus 1 and minus 2a uij k plus 1. We can just separate it out and we can just write in a combined form as if del x equals to del y, since we are just considering here uniform grid sizes. So, this means that whatever this grid length we are just considering in the x direction, the same grid space we are just considering in the y direction here. So, after putting all these values, we can just find that minus r ui minus 1 j k plus 1 plus ui plus 1 j k plus 1 plus 2 into 1 plus 2 r, since it is like 4 terms that is present in the form of uij to the power k plus 1 here. And if you will just see here one term that is just represented here 2 uij k plus 1 without the multiplication of r term, which is defined as del t by del x square here. So, that is why this 2 is present here, and minus r uij minus 1 k plus 1 plus uij plus 1 k plus 1 here, and the right hand side all the known terms that is in the power of k all are present here only. So, if you just vary this values from I equals to 1 to m minus 1 and j equals to 1 to n minus 1. So, we can have like m minus 1 into n minus 1 system of equations, and each time step we have to solve this m minus 1 cross n minus 1 system of equations while the scheme should be stable. And for the stability of the scheme we should have to choose that del t and del t into 1 by del x square plus 1 by del y square, it should not be restricted with any value for the Crank-Nicolson scheme, since already we have defined that for the explicit approach this should be less or equal to half there. And if you just go for the solution of parabolic equation, so with a specified boundary condition, suppose if we are just considering here as del u by del t equals to del square u by del x square plus del square u by del y square, where x is lying between 0 to 1 and y is lying between 0 to 1 for t greater than 0. With the initial condition means we are just prescribing all of the space coordinate values at t equals to 0 point, that is especially defined as x plus y here. And the boundary conditions are imposed for t greater than 0, since the boundary is fixed and it will not change with respect to time. So, that is why it is just written as t greater than 0 here, and which is defined as in the space coordinates in the x direction at x equals to 0, this normal derivative or del u by del x equals to u here, and at the last boundary, that is x equals to 1, we are just choosing u of 1 y t, this equals to 1 here. And for y equals to 0, it is just given that u of x 0 t, that is 1 here, and the derivative condition, that is del u by del y at the last boundary, that is just considered as a minus u there. And it is asked that find the solution using explicit method for only 2 time steps, taking del x equals to del y, this equals to 0.25 with time increment del t as 0.01. and approximate the derivative boundary condition by forward and backward differences as required. Since already we have shown that whenever we are using this derivative boundary conditions at this initial boundaries or at the first boundary, we are using forward difference approximations, and at the last boundary if we are just using, then we are just using this backward difference approximations. And if this equation is just given with these conditions, then we can just format it in a manner that at best it can require one more extra condition or a fictitious boundary at the last boundary, since at y it is just given as a del u by del y equals to minus u at y equals to 1, and at the first boundary it is just given a derivative boundary condition at x equals to 0, that is as a del u by del x equals to u. So, that is why at these points if we will just use like central difference approximations, it requires a extra fictitious grid space for the calculation. So, if you will just write all these boundary conditions in a compacted form, so it can be written as like del u by del x at 0 y t as u and u of 1 y t equals to 1, and u of x 0 t, this is 1 here, since x 0 t means at y equals to 0, we are just considering this boundary here. And if you will just consider like x equals to 1 here, that is nothing but we are just considering a sorry, this is x equals to 1 if you are just considering this is as 1 here, and if it is considered as y equals to 1 here, we are just considering this is minus u here, and the space length that is considered as a del x here, which is defined as a 0.25 here, and del y is the space length or the grid space, which is considered in the y direction as a 0.25 here also. So if you will just proceed with these values, then this formulation can be written as like for del x equals to del y, since uniform grid size already it is given in the problem, then this explicit method can be written as uij to the power k plus 1. This as minus r ui minus 1 j k plus ui plus 1 j k plus 1 minus 4r uij k plus r into uij minus 1 k plus uij plus 1 k here, where r is defined as a del t by del x square. And we have to keep it in mind that whenever this r value should be less or equal to half, then the system will provide us a solution here for this explicit scheme. And for this, if you will just find this r value here, r can be written as a del t by del x square, so which is defined as a 0.01 by 0.25 whole square, that is nothing but 0.16. And if you will just use these values, so we can just get this value as like uij to the power k plus 1, that is defined as here 0.16, since it is less or equal to half, you can just say. So that is why we can just use this is explicit approach to get the solutions. So after putting all these values like r values, so we are just reducing this equation in this form here. And since the question is given like 2 steps we have to move here, so I is varying from 1, 2, 3, 4. Since one more boundary it is required in the j direction also, so j is varying from 1 to 3 here. So for I equals to 0, if you will just use like forward difference along the boundary, we will have like u1j minus u0j at k plus 1th level by del x. This is just defined at u0j at k plus 1th level. Since the boundary initial boundary condition it is not provided exactly at the point u0j, so u0j can be taken this value as in the form of like 0.8 u1j to the power k plus 1 here. If you will just see here, that is this equation is separated in the form like since del x is first multiplied with here, so we can just write as u0 j k plus 1, that is del x plus 1. So this equals to especially u1j k plus 1 here. So that is why they say if you will just divide this one as del x plus 1 here, so del x is defined as 0.25 here. So 0.25, so 1.25, so 1 by 1.25, that is not especially 0.8 here. So that's why it is just written as u0j to the power k plus 1. This is 0.8 u1j k plus 1 here, and this value will be updated from this like the value that has been considered as u1j to the power k plus 1 here. And especially whenever u1j will be computed by considering suppose the last boundary here, and that value will be taken in the preceding manner and it can be updated with this value for this value here. And for j equals to 4, using backward difference for boundary condition, we can have like ui4 to the power k plus 1 minus ui3 k plus 1 here. By del x, this can be written as minus ui4 to the power k plus 1 here, and ui4 to the power k plus 1, this can be also written as 0.8 and ui3 to the power k plus 1. Same thing also here, this boundary value, this can taken the like inside computed value, and it can be updated in each of the time steps and it can be used in the computation process. So if you will just consider this value like for all these boundary values, that is for u4j k plus 1, especially if you will just see here, that is nothing but we are just fixing this last boundary as I equals to 4 here, and j is varying like j equals to 1, 2, 3, 4, especially we are just varying, and all of these values we will have this boundary condition as 1 there. And especially if you will just see here the same condition for like y equals to 0 here. So we are also fixing this same boundary condition along this boundary here. So that's why this boundary condition values are written in the form of u for j k plus 1 this equals to 1 equals to ui 0 k plus 1 for all time steps, and I j are varying from 0, 1, 2, 3, 4 there. And if you just use this initial condition like u of x y 0 as x plus y for t equals to 0, we can just get, since if you just see here I is marching as in the form of here as 0, 1, 2, 3, 4, and j is also marching here 0, 1, 2, 3, 4, and especially the values for y is prescribed as like 1.0, 0 0.75, 0 0.5, 0 0.25 and 0 here, and the values are given as like if you just see here like x, it is just prescribed as like 0, 0.25, 0.5, 0.75 and 1 here. And if you just consider like all of these coordinates here, like u of 1, 1 coordinate, suppose if I will just consider here, so then it can be written as like x1 plus y1 here. So all of these values that is just prescribed, that is just written in the summing form over here. This means that if you just consider like I equals to 0 and j equals to 0, the values are here like 0.0 and this is also 0.0 here. And if you just compute all these values at time step t equals to 0 here especially and put all these values, then we can just obtain these tabular values in this form here. Since this is nothing but a sum of x and y we are just considering, so whatever these values x and y, it is just given here, that has been computed in the terms of u, and it is just putting in the table here. So once this table has been formulated, so that just given us this u coordinates or the u values at each of these grid points. So then we can just use these grid points values for the further calculation of the values. So for I equals to 1, if you just write, the scheme can be written in the form of u1j k plus 1. This can be written as 0.16 into u0j k plus u2j k plus 0.36 u1j k plus 0.16 u1j minus 1 k plus u1j plus 1 k here. So especially if you just see here the scheme, so that is nothing but it is just written as like uij to the power k plus 1. It can be written as 0.16. Since only these coordinate values we are just putting here like I equals to 1 or I equals to 2 or I equals to 3 or I equals to 4, and j is varying like 1, 2, 3, 4 there. So if you will just put all these values, then for I equals to 1, 2, 3 here, we can just obtain this expansion of this equation as in the form of u1j, u2j and u3j here. And if you will just go for the solution of these three equations for j equals to 1, 2, 3, then we can get the required solutions as like for u for j, since these are all boundary conditions, so it is already fixed. So for all time steps, if you will just vary here like I j equals to 0, 1, 2, 3, 4 here. So for t equals to like 0.01 here, since we are just moving to the next time step, and k plus 1th level we are just calculating all these values. So in this step, if you will just put all these values, then we can just get these values are in this form here. So for different levels, if you will just see, this represents these values of u at t equals to del t level, that is 0.01th level. And these values can be used for the further or the next step of calculation of u values for j and I coordinates. So if you will just use these previous values at t equals to 0.01, we get the solution for next time steps, that is in the form like t equals to 0.02. So I is varying from 0, 1, 2, 3, 4. So here, and j is varying from like 0, 1, 2, 3, 4 here. So the values are coming, since these boundary values that are already fixed here. So only this inner values it has been calculated. So based on this previous table values and using this formulation. So we are not changing anything there. Thank you for listening this lecture.